Okay, so let's go back to these ones here. So we've got these benzene rings. So probably which one is going to have the lowest boiling point? This one, A, because it's just the ring. That one will have the lowest boiling point, okay? Now, which one will have the highest boiling point? If we look at B, B has, so it's got the ring, it's got this chain of carbons, but it's got this alcohol group on the end. So that means that this one can form hydrogen bonds, which this one just has the carbon ring. So this one has London dispersion forces. This one has the double bonded oxygen. So this one will be a dipole-dipole force. So this is the only one that forms hydrogen bonds, which is the highest here of all the different IM forces, since we don't have any ionic bonds. So this is going to be the highest. This one's going to be the lowest. Okay? Since this one does have some sort of intermolecular force that's going to operate, it's going to have dipole-dipole forces, where this one doesn't have anything except for London dispersion forces. This one will be third, this one will be fourth. Okay, do you sort of get what that's going, how to answer these? First, look at types of forces. Next, look at length of the chain. Okay, especially if it looks all kind of the same. Okay, let's look at some, I'm not going to go through all of them. If you have any specific questions about any one, you can come and ask me about it as well. So this one, what do you notice? So they all have an alcohol group, a hydroxyl functional group on the end. So that means the IM forces of all of these are going to be the same. The only thing that's going to be different for any of these is going to be the length of the molecule. So the longest one will have the highest intermolecular force. So this one is the longest chain. It's going to have the highest boiling point. This one's the lowest, smallest number. It's going to have the lowest number. And then this one will be second highest. This one will be third. Okay. This one is pretty straightforward. This is just a chain. All it has, since we don't have any ionic forces, we don't have any hydrogen bonding, we don't have any dipole-dipole, all we have here are London dispersion forces. So here we just need to look at the length of the molecule. So this one is going to have the highest boiling point, this one is going to have the lowest one, this one's going to have the second highest, this one's going to have the third highest. Okay. So 3 is a little bit trickier because we got different lengths, but we got different forces that are going on. So I think it's clear to see that B will have the highest one. It's got the longest chain of carbons, plus it's got hydrogen bonding with this oxygen group on the end. Okay, so B at least is the largest. C, I'm going to guess because it's got the shortest chain, and it wouldn't have any, it might have, so it's got an oxygen there. It probably would allow for some hydrogen bonding, but at least C, I would say, with the lowest carbon chain is probably going to have the lowest boiling point. So A and D are relatively similar. A is longer than D, so it's at least going to have the third highest boiling point, and D then will have the fourth highest boiling point. Okay, this next set of problems deals with branching. So remember, the more linear a molecule is, the higher the boiling point it will have. The more branched or spherical the molecule is, the lower the boiling point it will have. So This one is the most linear. It would have the highest boiling point. We can see that here. This one is the most branched, or if we looked at it in a 3D configuration with electrons, it would appear the most spherical. So it does have the lowest boiling point, and the experiments confirm that as well. So we'll just look at one here. So they all have the same kind of functional groups attached. It means they'll all have similar ion forces, intermolecular forces that are operating. Okay? The only difference is one is linear, the other ones are branched. Branched. This one is linear, this would have the highest boiling point. Okay? This one is the most branched. C, let's just make sure, would have the lowest boiling point. Might be a good idea to find the one that's the highest and then the one that's the lowest. Okay? Next, this is challenging. 1, 2, 3, 4. 1, 2, 3, 4. A and B, and I don't even know why this is in here. And even the question, the answer says it's harder to predict. So I'm not sure what that would do. So they've got the same length of carbon. They've got the same functional group. I'm not sure what that would do with the one attached to that branched methyl group compared to the end of the chain. And it even says it's harder to predict. So this one, as long as you knew that this one should have the highest, this one should have the lowest, these two you'd have to determine experimentally. Okay, these ones here, this is pretty easy. Which one do you think has the highest boiling point? Well, the benzene ring that's got the direct straight chain on it. This one would have the highest boiling point. This one would have a lower boiling point, and in fact, that's what they do find experimentally. So look at these, practice these over. You will have a few ranking boiling point questions on your exam. Remember, these are general trends that you need to use to figure out what the answer is. If you want to know what the exact answer is, then you have to do these in a laboratory. Okay? Have a nice day. Please study.